Hello and welcome to Mech Zone. In the previous lecture we have already finished the chapter of governors, and today we shall be starting with a new chapter, that is kinematic analysis of slider crank mechanism. So this is a very simple, very small and important chapter because इसमें से भी 1 or 2 marks questions can be generally asked. ओके सो आई वुड लाइक टू रिक्वेस्ट यू ऑल कि अगर आपने अभी तक हमारा चैनल सब्सक्राइब नहीं किया है तो हमारे चैनल को आप सब्सक्राइब कर लीजिए और बेल आइकन को भी प्रेस कर दीजिए ताकि सारे वीडियो के नोटिफिकेशंस आपके पास टाइमली पहुंच जाए. सो एक्चुअली वी विल डिस्कस अबाउट द स्लाइडर क्रैंक in this chapter and we would be deriving the expressions for velocity and acceleration. Okay, so let me draw the diagram. The hatched portion is generally fixed and hence this becomes a mechanism. This point is A, say this point is O, and A point is actually rotating. Okay, A point is actually rotating such that this is R, that is the length of the crank. L is the length of the connecting rod. This angle is actually called as beta. This angle is called as theta. And what we will do is we will drop a perpendicular from A on this line and such that this is equals to M. And when the crank is at this position, so this position is known as the inner dead center, or it is also known as the top dead center, and the extreme opposite position is known as the outer dead center or the bottom dead center. Okay, so what we are going to discuss here is about, say this slider is actually moving or it is reciprocating in this cylinder, and this displacement is actually, let us say, as x. So this displacement is x. Okay, so what is M? M is the mass of reciprocating parts. Let the mass of the reciprocating parts be M. R is the radius of crank, which is this, and L is the length of connecting rod. L is the length of the connecting rod such that L upon N is equals to, L upon R is called as N, and this N is called as obliquity ratio. This L upon N is called as the obliquity ratio. Now since the crank is the smallest link and the connecting rod is the largest link, क्योंकि जो हमारा crank होता है वो सबसे smallest link होता है और हमारा connecting rod सबसे largest link होता है, therefore n की value is very large. n की value generally बहुत large हो जाती है. Let us say omega, ये जो हमारा crank है, it is revolving with an angular velocity, say omega, in the clockwise sense. So it is the angular velocity of crank, and theta is actually the angle turned by crank from top dead center to bottom dead center. So actually top dead center or bottom dead centers are treated as reference points. They are treated as reference points, and we also know that omega is equals to d theta by dt. Omega is d theta by dt. So first we will discuss about the piston or slider motion. Okay, now the displacement of the slider, displacement is equals to x, such that x is equals to L plus R minus L cos beta plus R cos theta. I am not focusing on how I am deriving this, but the final expression that I will derive, I will be more focused on that relation. So we have to keep in mind this diagram. Please keep this diagram side by side. This point is B. Okay, this point will be B. This is O. This is M. And all the points have been labeled. Okay. So this displacement reciprocating, this is known as X. So on the side I would write down the relations N is equals to L by R such that L is equals to NR, and AM from the diagram is equals to L sine beta, it is equals to R sine theta. Okay, such that sine beta is equals to sine theta upon N. Please remember this relation. This is very, very important. Now we will substitute these values in this above relation, and we see L is equals to NR plus R minus NR under root of N square minus sine square theta minus R cos theta whole upon N. So N and N will be cancelled out. On taking R, 1 minus cos theta plus R, N minus under root N square minus sine square theta, and from here we can say cos beta is equals to under root 1 minus sine square theta upon N square. So X is equals to R 1 minus cos theta plus N minus under root of N square minus sine square theta. This would be the relation for the displacement of the piston, that is R 1 minus cos theta plus N minus under root of N square minus sine square theta. So this is a very, very important relation, and we definitely have to remember this formula. Now if we need to find out the velocity, so velocity is simply dx upon dt, and this can also be written as dx upon d theta into d theta upon dt, and d theta upon dt is nothing but it is omega. So, and we also know that v is equals to r omega dot sine theta plus sine 2 theta upon 2n. This is the formula for velocity. So v is equals to r omega sine theta plus sine 2 theta upon 2n. Okay, and this is important formula because many questions have been asked directly formula wise. So I request you to kindly remember all the formulas. You have to mug up these formulas that I have been inboxing in every of my lecture, so that you are directly able to solve the problem and you don't have to derive any formula in the examination hall. Now we come to the acceleration. So acceleration would be simply dv upon dt. It is equals to dv upon d theta into d theta upon dt, and we know that d theta upon dt is simply omega. So acceleration becomes r omega square cos theta plus cos 2 theta upon n. It is acceleration is equals to r omega square cos theta plus cos 2 theta upon n. Okay, so this is actually the formula for acceleration for the piston or slider motion. Now we shall be discussing about the connecting rod motion. Now the formula for the omega of the connecting rod, that has I am abbreviating as omega CR, it is equals to dB upon dt, where beta is actually the angular displacement of connecting rod, and we know that sine beta is equals to sine theta upon n. So we will differentiate both the sides with respect to t, and we will obtain cos beta d beta upon dt is equals to cos theta upon n d theta by dt, such that dB upon deta is actually the omega of the connecting rod. So omega of the connecting rod simply becomes omega cos theta into omega upon n. So omega of the connecting rod is equals to omega cos theta upon n into omega. So omega of the connecting rod can also be written as omega cos theta upon n under root of n minus sine square theta. And since theta is very small, this can nearly be tended to 0. So the final expression of the omega of connecting rod simply becomes omega cos theta upon n. Omega cos theta upon n. Now one more reason why we are neglecting this, because n is very large as compared to sine square theta, and hence we can neglect sine square theta. So this is the main expression that we have to remember, that is omega CR, that is omega of the connecting rod, is equal to omega cos theta upon n. Now we will look for the alpha CR, matlab angular acceleration of the connecting rod, and alpha CR is nothing but d by dt of omega CR. So this would be simply d omega CR d theta into d theta by dt. So alpha of the connecting rod simply becomes minus omega square upon n sine theta. So this would be the formula for angular acceleration of the connecting rod. So all these formulas have to be remembered by heart, because the direct questions will be asked from this section. Now after the kinematic analysis, now we will start the very important, that is the dynamic analysis of single slider crank mechanism. I am simply writing SSCM. So the first force that we will find out is the effective driving force to drive the piston. So piston को जो force drive करेगा उसको हम लोग उसका expression derive करेंगे, and this force is also called as piston effort or simply F. It is also called as piston effort or simply F. Now before discussing, I will again draw the diagram of single slider crank mechanism. The cylinder is fixed because it is a mechanism. This is point B, this angle is beta, this angle is theta, the crank is rotating and the slider is reciprocating. Say it is rotating with omega. This point is A, and the force which is acting on the piston, that is F, this is the piston effort. Now some component of this force will be acting along this line, and some component of this force would be acting along this line, and some would be acting perpendicular to this. So this is FC. FC, we will see what is actually FC. This is actually FN. FN is actually FC sine beta. This is FC cos beta. This is force in the connecting rod. Okay, FC is the force in the connecting rod, F is the piston effort. So the component of FC along this line, if it is actually FC cos beta, and this is FC sine beta. Okay, so this is FT and this is FC, such that this angle becomes theta plus beta. Okay, this angle is theta plus beta. This angle, this force is actually FR. Okay, this force is FR. Now we see there are actually two types of forces while deriving the piston effort. One are the supporting forces. Okay, the supporting forces are actually considered double acting cylinder. If we are considering the double acting cylinder, then the gas pressure force, say P1 and P2, these are the pressures of the gases at the cover end and the crank end, and A1 and A2 are the cross-sectional areas of the piston at the cover end and the crank end. D is the diameter of the piston. Small d is the piston rod diameter, such that A1 is equals to pi capital D square by 4, A2 is equals to pi by 4 D square minus small d square. So we see that on this piston we have P1 A1 from this direction and P2 A2 from this direction. So this is actually supporting the direction of F, so it would be called as a support, and this is acting opposite to the direction of F, so this would be called as oppose. Okay, such that the force of the gas is simply the difference between P1 A1 and P2 A2. Okay, so we saw that the supporting forces are the gas forces, and in the opposition forces we have the inertia forces. So inertia forces are the type of opposing forces, and the magnitude of these inertia forces can be simply mass into acceleration, and acceleration we know that it is r omega square cos theta plus cos 2 theta upon n. Okay, so if we talk about kinetic friction, so in case of the kinetic friction it is actually plus minus F. Plus means it will be supporting and negative means it will be opposing. Okay, so this is plus F, this is minus F. So F can also be written as F of gas minus inertia because it is opposing, plus minus F and plus minus mg. This would be considered only in the case of vertically placed engines. Vertically placed engines के केस में हम लोग m into g use कर लेंगे. Okay, now the second force that we have to calculate is Fc, that is the force along the connecting rod. Force along the connecting rod, Fc cos beta is equals to F. तो अगर हम अपने डायग्राम में देखें, Fc cos beta is actually equals to F. So from here Fc is equals to F upon cos beta. So we have to remember this formula. Okay, now the next thing or the next force that we have to calculate is the normal thrust to cylinder walls, and this normal thrust to the cylinder walls is actually Fn is equals to Fc sine beta. Fn is equals to Fc sine beta, and Fn can also be written as F tan beta because Fc was actually F upon cos beta. तो Fc को यहाँ हम कर देंगे F upon cos beta. Okay, so this becomes Fn is equals to F tan beta. Okay, now the fourth point is, or the fourth force is radial thrust to crankshaft bearings. Radial thrust to the crankshaft bearings, it was actually the Fr. This was the radial thrust to the crankshaft bearings. So Fr is actually equals to Fc cos theta plus beta. So Fr simply becomes F upon cos beta into cos of theta plus beta. So this would be the expression for radial thrust to the crankshaft bearings. Now the next force that we will derive is the crank effort. So the crank effort is denoted by Ft that we have already shown in this diagram. It is Ft. So Ft is actually equals to Fc sine theta plus beta, or it is written as F upon cos beta sine theta plus beta. This is the expression for crank pin effort. Okay, so the last force that we have to find out. The sixth one is the turning moment on crank shaft. So turning moment on the crankshaft, T is equals to Ft dot R. So T is equals to, we will write the value of Ft, that is F upon cos beta sin theta plus beta into R. तो यहाँ हमें पता चला कि जो हमारा टर्निंग मोमेंट है T, इट इज एक्चुअली अ फंक्शन ऑफ थीटा. इट इज एक्चुअली अ फंक्शन ऑफ थीटा. तो ये जो हमारा T थीटा क्या हो जाएगा हमारा, दिस वुड फॉर्म द बेसिस फॉर टर्निंग मोमेंट डायग्राम. टर्निंग मोमेंट डायग्राम ऑफ इंजन, वेयर थीटा इज एक्चुअली अ फंक्शन ऑफ टाइम. जो हमारा थीटा है ये टाइम का फंक्शन हो जाता है. तो हमारा जो टॉर्क है, दिस ऑल्सो बिकम्स अ फंक्शन ऑफ टाइम. टॉर्क भी हमारा टाइम का फंक्शन हो गया. और आपको पता है कि टॉर्क इज इक्वल्स टू आई इंटू अल्फा. सो आई इंटू अल्फा इज ऑल्सो एक्चुअली अ फंक्शन ऑफ दिस टाइम. नाउ सिंस I is constant for a system, I is constant for a system, so alpha actually becomes a function of time. That is, the angular acceleration is the function of time. The variable acceleration, since it is changing with time, so this is called as variable acceleration, and this variable acceleration is actually causing jerks which are even more dangerous as compared to just fluctuations. तो ये जो jerk produce करेगा ये बहुत ज़्यादा dangerous होंगे as compared to simply fluctuations. तो इसको remove करने के लिए जो device हमने, ये jerks को remove करने के लिए जो device लगाया वो था flywheel. और flywheel को कहाँ mount करेंगे? It is directly mounted on इंजन शाफ्ट. इसे इंजन की शाफ्ट पर डायरेक्टली हम माउंट कर देंगे. सो फ्लाईव्हील का मेन फंक्शन क्या होगा? फ्लाईव्हील का मेन फंक्शन होगा कि इट ट्राइज टू मेंटेन द टी वैल्यू ऑफ टी एज कांस्टेंट सो दैट अल्फा कैन ऑल्सो बी मेंटेन्ड कांस्टेंट. सो देखिए लेक्चर के खत्म होते हुए मेरी पेन भी खत्म हो गई. तो आप इसका इंडिकेशन समझ ही चुके होंगे कि विद दिस वी कम टू द एंड ऑफ दिस पर्टिकुलर चैप्टर. तो मैंने कोशिश की है इस चैप्टर को पूरा का पूरा सिर्फ 23-24 मिनट्स में कंप्लीट करने की, विदाउट लीविंग इवन अ सिंगल एस्पेक्ट ऑफ दिस चैप्टर. तो जहां इस चैप्टर का एंड हुआ है तो आप नेक्स्ट चैप्टर का भी हेडिंग समझ ही गए होंगे क्या होगा. यस, डेफिनेटली वी आर गोइंग टू स्टार्ट विद द नेक्स्ट चैप्टर, दैट इज फ्लाईव्हील्स. सो टिल देन डू हमारे चैनल को ट्यून्ड अप रहिए, क्योंकि हमारे अपने सारे वीडियोस नवंबर के एंड तक सब अपलोड कर दिए जाएंगे. आप लोग अपने हमारे चैनल के बारे में अपने फ्रेंड्स और अपने कलीग्स के साथ भी शेयर कीजिए बातें, ताकि उनको भी फ्री में बेनिफिट मिल सके, बिकॉज एवरीथिंग इज अवेलेबल एब्सोल्युटली फॉर फ्री ऑन दिस चैनल. So with this we come to the end of this lecture, and in the next lecture we shall be starting with the topic of flywheels. So thank you so much.